So since we had a detailed discussion on electric potential energy, electric potential difference, so today we will study it from your curriculum's perspective, and things will become much more easier. The first thing we will understand is electrical potential difference. Okay, today we go by your book's definition: electrical potential difference between 2 points. So this is your first topic of the day, electrical potential difference between 2 points. So let's say there are 2 points. A point is A and there is a point B. Okay, what did we understand? You have to do some work. Whenever you come to electrical potential difference, I hope you also know the difference between what is known as a test charge and what is known as a unit positive charge. There's a difference between the two concepts. Test charge is a charge which is shown as Q naught, whose magnitude is almost zero, but whatever charge is a little bit there, that is positive always. Okay, unit positive charge means I have a charge Q which is equal to 1 coulomb positive. 1 coulomb positive. This is unit positive charge. So when we talk about electric potential difference means energy difference, right? Energy difference. So it's not electric potential energy difference. If I say electric potential energy difference means something is in joules, right? Potential energy. So you have to do a work. You have to do a work, and in this definition, you can bring any charge that you want. It's not only that unit positive charge, you can bring a higher value charge also. So we move a charge Q. Okay, I'm not saying what is the value of Q. You will be moving a charge from Q towards A. So it's like what? Suppressing the spring on this side. Where will be the potential energy more? At A, the potential energy will be more. Where will be the potential energy less? At B, it will be less. So electrical potential difference between 2 points. Okay, potential difference between 2 points. So we say that the potential at A is said to be VA. First, let us see mathematically, then it will become very easy by definition. The potential at B is said to be VB. Why did I write A on this side? Final potential minus initial potential, right? This is potential, not potential energy. But we know potential energy only. And what is potential energy? The potential energy is all about a external work that you are doing. How are you doing the external work? In moving the charge from B to A, from B to A. See, the way I write, you're doing work to move from B to A. In this process, A gains more energy, B loses energy. So A gains more energy, B loses energy. But that is potential, not potential energy. So you equate it first by the work done, the external work done from B to A. But these two cannot be equal. This is potential energy. Potential energy or external work done. This is potential energy difference. This is potential difference. So potential difference is potential energy difference. Potential energy is same as the work done divided by the charge that you are trying to move. Whatever value of the charge it is, whatever value. Now just imagine, this is 50 rupees divided by 5 mangoes. What is the value you are getting? 50 rupees divided by 5 mangoes means what are you calculating basically? Price per mango. Price per mango. Work done per unit charge. End of the day, we need per unit charge. You can bring any charge. If you divide it by the value of the charge, it is work done per unit charge. So much of rupees divided by 200 mangoes. What is it? Price per mango. Price per mango. Work done per charge. Per charge. Right? Let's understand once again. We are moving a charge, maybe of any value, from a point B to a point A. In doing so, I am sweating. I am doing an external work. So there is an energy difference between the 2 points, which we learned that day. What is the energy difference? UA minus UB. This is the energy difference. This energy difference is known as delta U. And what is this energy difference? It is the external work, jo pasina aapne bahaya, the sweat that you have poured out. That work is stored as potential energy. This potential energy difference, if you divide it by Q, so you are dividing this also by Q, you are dividing this also by Q, you get something which is known as potential difference. And what is potential difference? Higher potential minus. See, it becomes so easy now. So what is electric potential difference? Electric potential difference between 2 points. पहले लिखो, समझो अब हमेशा समझो पहले, then you can write on your own. Electric potential difference between 2 points is said to be the external work done in moving a unit positive charge, or you can say external work done per unit positive charge. Either you move a unit positive charge or you move any damn charge. Then you say work done per unit positive charge in moving per unit positive charge from one point to the other point. So the electric potential difference between 2 points is the work done in moving a unit positive charge from one point to the other point. When you move, then you do some external work. When you move, you do an external work. This external work is stored as the energy difference. When the energy difference is divided by the charge, you get the potential difference, delta V. And delta V is VA minus VB, which is the final potential minus initial potential. If I have two heights like this, water will flow always from higher potential to lower potential. Every body wants to come to lower energy state. I hope you know that. If energy is more, you are unstable. This child, as long as he doesn't sleep, he creates a ruckus in the house. That means he has more energy. The moment he sleeps, no energy at all, the house is ekdam shant. Imagine yourself, I make you sit on a bus, you feel comfortable. I make you stand, your energy is more, so you start holding. I say, no, beta, go and stand on the roof of the bus, and I drive the bus. The first thing you will say is, main baith jata hu pehle. The more lower you come, your energy is less. So everybody wants to come to lower energy. Water will flow from higher height to lower height. Charges will flow from higher potential to lower. Now this is our higher potential. This is our lower potential. So this charge will go from here to here. From lower to higher never happens. You have to do work. If you want to pull water from the ground to the top, you have to run a motor, a pump, spend electrical energy, mechanical energy, potential energy. But from top to bottom, you need not do these things at all. So electric potential difference. Now you want to write? Now we can write, okay? Electric potential difference between 2 points is defined as the external work done, is defined as the external work done in moving a unit positive charge between the 2 points. Between the 2 points. The quantity, this quantity called, the quantity electric potential. We are right now defining electric potential difference. Electric potential, the SI unit of this is known as volt, named after Professor Alexander Volta. Okay, this is volt, right? So we can define, when do you say that the electric potential, how to define the electric potential difference of 1 volt? The electric potential difference between 2 points is said to be 1 volt when 1 joule of work, external work, is done to move a charge of 1 coulomb between the 2 points. अब देखो कितना easy हो गया है. What do you understand by electric potential difference? The electric potential difference between 2 points is the external work done per unit charge, or we say external work done to move a unit positive charge from one point to the other. In such a case, the system gains a potential energy which is given by delta U equal to UA minus UB. If you divide it by Q, you get delta V. Understood? And this delta V is WEXT by Q. You can write this whole thing. Now your concept is absolutely clear. So we say electric potential difference between 2 points is defined as VA minus VB, which is delta V. And they say define 1 volt. If somebody says define 1 volt, 1 volt is said to be the potential difference between 2 points when external work of 1 joule is spent in moving a charge of 1 coulomb from one point to the other. ठीक है ना? So in same lines with this, our next topic is electric potential at a point. Electric potential at a point. And this definition will become more clear from the above definition. So what did we find the definition out here? We said delta V is VA minus VB, which is equal to W external when you're moving from B towards A divided by Q. Now you don't want difference. You want the potential at a particular point. So I want what is the potential at A. So basically you will be calculating again difference, but you have to have some sort of a assumption now. And what is the assumption you do? You want to calculate the potential at A, means you want that your delta V should only give VA. This is possible if this is made 0, if this is made 0. And this can be made 0 when B is changed to infinity. So this B will change to infinity. So now it becomes more easy for us to define what is electric potential at a point. The electric potential at a point, now since you don't have a Q, now the thing that comes up is a test charge, mind you. When you're defining electric potential at a point, then the concept is a test charge. Is the work done in moving a test charge from infinity to that point? Infinity to that point, right? So now we write electric potential at a point is defined as the external work done in moving a test charge from infinity to that point. So you can write the potential at A is said to be the external work done in moving a charge from infinity to A. Moving what charge? Test charge. External work done. This actually in your books, this will be explained first, but I find it very irrelevant. This should be explained first, then you have, right? So now clear, these are your first things. Shall we go ahead? So, sir? Yes, sir.
Sir, why a test charge?
Because if you don't move a test charge, then you will be, that's why previous class knowledge is required. You have to go to the previous class. If we don't move a test charge, the charge itself will influence the potential at that point. I told you an example the other day. I am taking you as a tester of food to a restaurant. I cannot take you with your tummy full. Then you will not taste any food at all. I have to take you almost hungry. Slight food in your stomach so that you are able to walk, but not completely filled. Otherwise, you will not eat what will I serve you at the restaurant. You have come to test the food at that restaurant. Okay, na? So it's always the test charge. Okay? So while this is gone, let's see what is the implication for our syllabus. Now, when we talk about now some realistic talk, electric potential difference. Okay, electric potential difference, and this you are going to study. This will be coming up later as PD, potential difference. Potential difference can be mechanical potential difference also, but since we are studying electricity, in this chapter PD means EPD, but we will talk as PDPD, right? Understood? PD means potential difference. So the analogous terms for this in this chapter would be potential difference. Another analogous term that you'll keep on hearing while you do numericals will be voltage, right? So we say, for common sense, some examples like this is the plug point in India. It will be written 220 volts AC, means alternating current. And if this was the same thing in United States, it will be 110 volt AC. Okay. Alternating current we will do. Abhi karne se will go away. Okay. So this is 220 volt. This is 100 volt. This is voltage. It means if you consider this as a point A, then the potential at A is equal to 220 volts. Did you understand this? This is how you have to take it in numericals. If you consider this as a point A, this is 220 volt. And with this, as I said, I have connected my television. I have not switched it on. And my television is point B. My television is point B. Then I would say that VB is right now 0 because I have not switched on. So when you switch on, the charge starts flowing from the plug point to your television. Have you understood? And the potential difference, we will say how much, is 220. So in some questions, they may say the potential is 220 volts or the potential difference is the voltage is 220. Voltage means potential difference. Voltage means I went to the market and I have bought a new, you know the sizes of cells that we get, AA, AAA, 4A, we also get 4As also. Okay. So 4As are like used in stylus pens and also you have brought a AA cell, Duracell. So this is always the plus side. This is the minus side. We will see all these and the symbol is shown in this manner. Okay. This is plus side. Now this has a potential difference of 1.5 volt. A new cell, if bought from the market, should always show 1.5 volt if you connect it. Okay. Now 1.5 means what? The difference of potential between the terminals means this is the negative terminal, and this we show it with a bigger bar because this is taken to be the 5 volt. This is taken to be the 0 volt. This is the higher potential. The current will always flow from this to this. Understood? So in problems, when we say the voltage means potential difference, right? Or if we get problems where we say the potential difference, that also means voltage. Is this much clear? Right? So this brings the first formula for this chapter, and every day we do our chapter, we will be like a frog revising the previous formula and learning new formulas because this chapter is very, very formula intensive. The first formula that you will use only for this particular section, we know potential difference is always equal to final potential minus initial potential. This is a basic formula, right? The next thing that we should also know, potential difference is always equal to external work done in bringing a charge from initial to final divided by the value of the charge. This is another formula that we know. Okay? A generalistic formula that might come up from here is that the voltage is always given by the work done divided by the charge. These are same things. So these are the first three things that you should have in your kitty. Okay? Voltage is always potential difference. If I say that the voltage of the battery is 1.5, that means the difference between this and this. Your age is 14 years means the difference between today and the day you were born. It's always a difference. So whether you write V or delta V. That's okay? Itna samajh mein aaya? Very good. Shall we go ahead? Yeah, please.
That we have to put an external work for it to be 1
volt.
But we are not putting any external.
There's so much of external work from the turbine to the generator station they are doing. If you don't do work, why is your daddy then mummy paying electricity bill? Somebody is burning coal. Coal is getting converted into heat energy, chemical to heat to mechanical energy. Turbine is rotating, electrical energy, and that is constantly we are keeping it. These are not static. Every time there is a potential. It's not like thunderstorm, just only on during the strike of the storm, thunder, you get some potential. No, here there's a continuous feed. You eat or not, I'm continuously feeding it. You're paying me money based on what you use. External work then to hoga hai. See, the world is very beautiful. If you want things to happen like the world wants, get it free. You want the stone to fall from the hill to your head, no questions asked. We'll give a free of cost service. You want the stone from here to go and hit the parrot who is sitting on the treetop, you have to do some work. Right? Chale aage? Okay. Now, before understanding, so we got a fair bit of idea about what is voltage. Okay. Now, so the first Amar of this chapter has been introduced to you. I told you there are Amar, Akbar, Anthony. This is Amar. Amar is voltage. Voltage is measured with a unit which is known as V. Right? Again, I am writing While we calculate V, V is said to be W upon Q, where W will be measured in joules and Q will be measured in coulombs. So you should know what is the definition of 1 volt. What is 1 volt? 1 volt is said to be the potential difference between 2 points if a work of 1 joule is spent in moving a charge of 1 coulomb from one point to the other. Done? Okay. Now we will come into something called measurements. How do you measure voltage? For all these things, certain devices will be introduced to you. Before knowing those devices, let us understand some more facets about electricity. In electricity, we will be continuously hearing about two terms called series versus parallel. Series versus parallel. These are modes in which appliances are connected, series or parallel. Let's go by very simple topic. Series means I can have a device. That device can be connected in series or the device can be connected in parallel. We don't know what is series and parallel. The easiest way. Series is your childhood playing game. What did you play? You don't know? Ring-a-ring-a roses? How did you play ring-a-ring-a roses? All of you hold hands and play ring-a-ring-a roses. Abey yaar, kuch to bolo yaar. Have you played? Do you understand this? Otherwise, I will change and give some other example. Do you know what is ring-a-ring-a roses? I played. And we used to be very ashamed the day in childhood we used to be made to hold hands with girls. And that was nursery, na? That time you are very ashamed. And then you used to think in grade 10 if you could have played ring-a-ring-a roses, which you're never allowed to play again. Do you understand now? Now, how do you play ring-a-ring-a roses? You play ring-a-ring-a roses in this manner. This is called ring-a-ring-a roses. Correct? Now, what I do, I start coloring this child. This child is being colored. And this child is a device. Right? Connect this child. Imagine connect in series. So when you connect in series, you will connect it in this pattern that the child will also be one part in this chain link. Understood? So what I mean by that is that suppose I have a device which is an electric bulb. This is a bulb. Any device will always have 2 points, obviously, because to complete a circuit, the current has to go in through one and get out from one. So there will be 2 points. Every bulb, any motor, any speaker, anything that you see will have always 2 wires in it. Now you'll say, sir, my laptop has got 3 wires. That we will discuss later. So it has to have 2 points, right? Our intention is, how do you connect these 2 points? This is how do you introduce it? So the way I will introduce it, if the bulbs are connected in series, then I will expect my bulbs to be connected in this manner. Do you understand? These are 2 bulbs connected in series. They are connected like ring-a-ring-a roses. Not round change, सीधा जाएगा, सीधा, straight. Okay? So I don't know whether it's like this here. Yes. 2 batteries connected in series. Positive of one with the negative of the other, positive of one with the negative of the other. This is the best example that I could give. So connect 2 cells in series. Cell number 1 connected, cell number 2 minus plus minus plus. This is series. Got it? Did you understand what is series connection? इसको लेके बहुत बात करना है आगे जाके. The second one is known as parallel. Parallel means nursery children, I don't know whether you all do it or not. We used to do, go to the assembly. Okay, this is how you remember. Children go to the assembly. How do nursery children go to the assembly? One with the hands on the other shoulder like this. They used to walk to the assembly like just like that. So let's see. If I show one bulb in this manner, this is the first child. They're not supposed to do ring-a-ring-a roses now. Now they're supposed to go to the assembly. The next child will be like this. The third child will be like this. This is a parallel connection. Parallel, 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 parallel. Did you understand? Can you connect 2 batteries in parallel, 2 cells in parallel? Why not, sir? Positive, positive, disconnected, disconnected. This is a parallel connection. Negatives join with negatives, positives joins with positive. Why will they repel each other? They will not repel each other. They will repel as long as they are not connected in a circuit. We do this. Is this understood?
Yes.
Anyways, so you might think whenever we ask a question to this person, he gets angry. He doesn't get angry. He gets angry when you don't show minimum common sense. रिंगा रिंगा रोजेस ड्रॉ किया, असेंबली ड्रॉ किया, फिर भी पता नहीं है. हाँ भैया, क्या बोलूं? Potential difference measurement. Potential difference measurement is done by a device called a voltmeter. Okay, in daily practice, again, these are very old dated techniques you are learning. Nowadays, we don't use any voltmeter or anything. We use a device which is known as a multimeter, which can work as a voltmeter, which can work as a ohm meter, which can work as a... But in labs and all, still voltmeters are there. So what is a voltmeter? A voltmeter will be a device like this. It will be graduated like this. There will be a kata, right? There will be a kata associated with it. And there will be two connection ports in it, right? One port written as plus and one port written as minus. This is a voltmeter, okay? And it will be measuring volts depending on something. Now see, say this is a... Now when you go to lab, you'll learn. This is called the range of the voltmeter, the maximum. This is called range. 0 to 50 means, can I use this voltmeter to measure 80 volts? No. If you measure 80 volts, ये 50 में जाके ही रुक जाएगा. Have you understood? Can I use this voltmeter to measure 0.1 volt? Maybe yes, but maybe not accurately. Then I'll take a voltmeter of smaller range, 0 to 1 volt, where everything is 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, right? Different ranges for different job. This voltmeter cannot be used for checking our voltage of our switchboard. If you connect this to our switchboard, badlam, this will blast away, because it can maximum show how much? 50. The potential that it can, basically you are measuring the energy, na? The energy it can measure is up to 50. And you are trying to connect it on 250. Can it measure? It cannot measure. So how do you connect this voltmeter? So a voltmeter is always connected in parallel, or the better word we use is across the 2 points, across the 2 points whose PD is to be measured. Across the 2 points, whose PD is to be measured. Let us try to understand this. So suppose this is a wire, and this wire is carrying some voltage, and you want to measure what is the potential difference between these 2 points. So what do you bring? You bring a voltmeter. The symbol for a voltmeter, electrical circuits will always have symbol. The symbol for a voltmeter is V, like this, right? And it will have 2 fangs. So I bring my voltmeter, What is my voltmeter supposed to do? To measure the potential difference between 2 points. How do I connect it? In parallel. And if you don't understand parallel, across the 2 points. So I connect it across the 2 points. I've connected it across the 2 points. Whose potential difference you want to measure? How is the voltmeter now lying here? In a parallel to this line. Is this understood now? Right? Electricity, whenever you are studying, should be studied analogous to plumbing. Then your understanding becomes more easy. Plumbing. Plumbing means, what does plumbing mean? Water lines. Water pipeline network is known as plumbing. Put this along like a water line. Let's say this is a water line. You want to find out, say this is some house A, and the same line is going to some house B. You want to find out, A is getting water at very high pressure. B is not getting the water at very high pressure. So you want to find out, is there really a... Ideally, this fellow and this fellow should get water at the same pressure, but they are not getting. So how do you check it? You bring a pressure gauge. And how will you do? You will connect the pressure gauge here. You will connect the pressure gauge out here. And if the pressure gauge is reading a difference, that means some lafra is there. Some sort of clogging is there in between. That's why there is a pressure difference between the 2 points. Are you getting it? There's a pressure difference between the two flats. The two flats should get the same pressure. But we find that when we open the tap of the other flat, water is not coming out that much fast as it should. So there's a pressure, less pressure. They've reported, sir, pani nahi aa raha hai. So first thing what I will do in plumbing, I will connect a pressure gauge between the two. And if this pressure gauge is reading 0, 0 means whatever is the pressure here, is the pressure here poor, poor, rich, rich. Difference means either somebody is poor or somebody is rich. Is this logic working? So whenever you use a voltmeter, we will be actually calculating the voltage difference between 2 points. If the voltage difference between here and here is same, sorry, the voltage here and voltage here is same, the voltmeter should read what? 0. The voltmeter should read 0. Therefore, suppose this is my plug point. Now these you will never do at home, okay? These are just for understanding purpose. The plug points are designated as the earth point. You will have one live and one neutral. This is actually called the hot point. The entire potential is on that point. So this will be at 220, this will be at 0. Now if you connect a voltmeter out here, the voltmeter should read how much? This voltmeter should be reading 220. It shows that the potential difference between the two is 220. So when somebody is rich, somebody is poor. Is this understood? Then they say that how is the construction of a voltmeter? Now, in order to understand construction of a voltmeter, just for logic, we have to understand Anthony for short period, though we will study Anthony later. Anthony is somebody who is known as resistance. Okay. A resistance means you have a resistance. We ask you to go to Ratnadeep, you said, no, I'll go later. Everything you show a resistance. Something like inertia. You don't want to change. So resistance is somebody who does not allow current to travel. Current says, I want to go. Resistance says, no, jane nahi dunga. And the resistance like inertia or stubbornness or disobedience is inbuilt in you as a trait. Resistance is something which is inbuilt in a conductor. You might be less disobedient, she might be more disobedient. A conductor may have less resistance, another conductors may have more resistance. The more resistance a conductor shows, the more difficult it is for current to pass through it. The less a conductor shows resistance, the more easily current passes through it. Got it? If you are more obedient, we will go by disobedient. If you are less disobedient, that means you will take my orders very quickly. If you are more disobedient, you won't take my orders quickly. So we say that a voltmeter has a high internal resistance. Now let's understand why. Why does it have a high internal resistance? Let's see. For that, let us design one small circuit, okay? Though, try and understand. It won't be that difficult for you to understand. Say I have a cell, very simple circuit I am designing. I have connected it to a bulb. This is my simple circuit, okay? There's a cell which is connected to a bulb. Now, this cell is how much better? Commercially available will be 1.5 volt. This is plus and this is minus, right? I want to see that the potential difference across the cell is 1.5 volt. And this potential difference, in this potential difference, I have connected this bulb. Ideally, the bulb should also be sensing 1.5 volts only, right? Whether the bulb senses or not, I have understood that I want to measure the potential difference between, say, a point A and a point B. So what I do, I bring a voltmeter from the lab. So I connect the voltmeter is always connected across the 2 points. And this voltmeter is happily reading 1.5 volt. Have you understood? Whatever is the voltage here is reading the same voltage. So the bulb is right now subjected to 1.5 volts, right? I say that the voltmeter should have a high internal resistance. Let's now see what happens actually. Electric current is the flow of charges. We have not studied current, but absorb it. And the charges always flows from higher potential to lower potential. So the charge comes out of the higher potential. It started to come out of the higher potential. It goes here. Once I have connected my voltmeter, out here the charge has now a doubt. इधर जाऊं कि इधर जाऊं, है ना? उसको एक doubt में आ गया है. Is the voltmeter our appliance? No, the bulb is our appliance. The charge is like rotis that we are sending to our beloved boy. This is the parent and this is the child in hostel. We are sending him rotis. Roti should go to whom? To my child only, na? Should it go to the voltmeter? But I am with the voltmeter, I am checking paid bharai ki nahi, how much roti I send, which is getting the same rotis or not. So the roti, so the charge after going here has a option to go in this side. If it goes this side, the roti does not go to my child. So what the voltmeter does, the voltmeter internally, I'm just showing it outside, will have a very high resistance, which is like a no entry board. Even if the roti goes here, teet, 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 no entry. It comes back and it has to go. So it starts going through. See, if you allow water to go through two pipes and one pipe has a blockage, the water will come back and go through the other pipe only. The idea is, if the voltmeter does not have an internal resistance, then the current in the circuit will vary. Flow of charge is known as current. The current was supposed to go through my appliance, but the current got a route to go through the voltmeter. What I wanted to check, I am not able to. So the actual, and let's put it now into the plumbing concept. Plumbing makes everything understand very easily. Okay, let's see it in the plumbing concept. So let's see, this is say a house, right? And the house is being fed from the water supply point. We are feeding it good quality water, but the house says there is a huge pressure drop after this house. So we connect what? We connect a pressure gauge out here. Why did you connect the pressure gauge? To measure what? Pressure of water. Water pressure. If the water goes through the pressure gauge itself, don't you think that the house, you will not be able to measure what you wanted to measure? You wanted to measure what? The water pressure across the 2 points on the house. If you allow the water to go here, the house is feeling a lot of water pressure now. And that's what I want to measure. Water is gushing inside. You want to measure that. But to measure that, you introduced an apparatus, and this apparatus allows the water to go through here. So the pressure here reduces. So the measurement that you will make will always be wrong measurement. Same is the case with a voltmeter. A voltmeter should have high internal resistance. If a voltmeter does not have a high internal resistance, the current will flow through the voltmeter. We don't want it. The voltmeter is like a pressure gauge. It is supposed to measure the obstruction that the line is giving, the potential difference between 2 points. If you allow the current to go, the potential difference will fall. Charge to chala hi gaya, spring khul gaya aapka. Are you understanding? It does not, it doesn't want current. It is only suppose, why should I want to measure what is the, okay, tell me one thing. You are pushing this, you are pushing my palm. You're pushing my palm. I want to measure your strength. Should my hand come back? If my hand comes back, will I be measuring your strength? No. Jitna taakat lagana hai, lagao. So you're pushing here. I should not allow you to, this cannot bend. So if you allow the current to go through here, you're allowing it to bend. Where are you measuring potential? This is not supposed to measure current. Voltmeter measures potential. How much of energy is out here? You know, it's like that spring. You cannot allow, if the charge goes, then the spring has been elongated. Go back to our spring concept. The charge has to go through here, and then you are measuring the potential difference. See, one way is that you mug it up. It will say, the book will say, a voltmeter. In voltmeter, we have got 3 things to learn. A voltmeter is a device which measures potential difference. You can ask these 3 of them. They have done this chapter, so they must have mugged up these 3 lines. It is used to measure potential difference. It is always connected in parallel. At that time, nobody told them this water concept. Voltmeters are like pressure gauges. The problem with you all is that you all don't know also what is a pressure gauge. Have you filled air in some roadside tire shops? He will take 1 meter and then he will jack it. That's a pressure gauge. What is he doing? He is actually connecting his gauge with your tire. And once he inserts it, the sound will be there. So it has connected with your tire. The entire air of the tire is now coming and hitting this particular device. So it tells him how much is the tire pressure in your particular wheel. Have you got it? So a voltmeter is used to measure potential difference, number 1, or voltage. If you want, I can write it for you, not an issue. But my question is, did you understand or not? A voltmeter measures PD or voltage. This is statement 1. Statement 2, a voltmeter is connected in parallel or across the points whose potential is to be measured. Now, there might be one thing, sir, your examples make it more complicated. I give an example because if you mug it up this way, there is majority chances that you might also forget. And when you forget, because the next apparatus we will learn will be connected in series. Or 4 mahine baad, when you go to exam, you will have a doubt, first potential series or parallel, then you will do inky pinky minor mo and you will click one. But if your logic is clear, you don't need to mug up this thing. I work with electricity or electricals or electrician. I can never think in my life to connect a voltmeter in series because वो काम ही नहीं करेगा, उसका काम ही वो नहीं है. It's as good as somebody wants to test his arm twisting power with me, and what I do? हरा दो मेरे को, हरा दो. Am I testing your strength? No. I'll be an idiot. If I want to strength, I will hold it like this. Now bend. How much? ठीक है, और लगाओ, bend. I will have high internal resistance because I want to measure your potential, your strength. That's why I give you a logical explanation. And if the logical explanation becomes difficult, because when I give logical explanation, I expect questionings. Then only this thing, because the example I'm giving is very clear in my head. The example is for the first time in your head. So if you don't question, it means you are obeying whatever I'm saying. And then there is 90% chance you will not like the example, which happened in his case. I'm not blaming him. You will not like the example, or you will not understand the example, or the example in the worst scenario will make the topic much more tougher than what it is exactly. My fear is the third one, because I find your realistic experiences are very less. Therefore, I go back to just as his school did. ज़्यादा रिस्क नहीं लेने का, बच्चों को पढ़ा देने का. A voltmeter has high internal resistance. ये 3 नोट कर लीजिए, जरूरी है आपके लिए. This is needed for your grade 10. कोई फायदा नहीं है, वो मेजर नहीं करेगा. You can ask the same question like, what happens, sir, if I am testing my arm strength with you and you bend and lose the match? No. The machine itself, there will be, if you buy the Decathlon air pump, then you have a pressure gauge in that. The pressure gauge initially will show 0. So when the moment you connect your hose into the tire of your cycle, there is some remnant pressure in your tire. Unless it is 0, the pressure gauge will immediately show some deflection. That is now the current pressure, and you start inflating from there, so it starts increasing, and there will be a point where you feel that this is sufficient, and you take out. What did you actually check? You actually check the pressure difference of your tire with that of the atmosphere. As compared to the atmosphere, my tire is pressurized. इसीलिए तो टायर फूला हुआ है ना. If the tire is not pressurized, the tire should come down like this. Why do you buy a very fluffy chips packet? Because it is pressurized. If it is not pressurized, the chips packet will be this thing. Yes, sir. No, that is a tachometer. The one which shows you RPM is something which will show you rotations per minute or revolutions per minute. That's called a tachometer. That's not a pressure gauge. A pressure gauge will be there only to sense pressure. Next time you see a water hydrant, you know what is a water hydrant? Every water hydrant point, what is the water hydrant supposed to do? The fire water hydrants are always charged. In our apartments, the red pipes which you see, they are all fire water pipes. They are every time charged, full pressurized, because in emergency, we just need to open. In order for you as a resident, you should not be always dependent on that plumber. When you're taking your evening walk, right? In our apartment, beside some H tower or something, you have that. On the sides, if you go K tower, you'll find some fire hydrant. Just have a look at the pressure gauge. The pressure gauge should be reading and showing pressurized pipe. If the pressure gauge is showing 0, that fire hydrant does not have any water inside it. As simple as that. That's how. How does a nurse get to know that the patient's oxygen cylinder is over or not? The oxygen cylinder will also have a pressure gauge fitted to it. It measures how much of pressure is there. As the gas content reduces, the pressure gauge starts falling. Simple. So if you connect a voltmeter, say suppose now for example, this is my room clock. The room clock has got a cell inside it. Yes or no? How long does the clock run? As long as the cell has got its potential. The day the cell's potential ends, the clock stops. Clear? I connect two wires from here and I connect a voltmeter. Say this is a digital voltmeter. On day 0, when I connect, it should show how much? 1.5 volt. 3 months gone, its voltage should start reducing. And then you will one day find then when its voltage has become around say 0.7, watch clock has started becoming slow, like my clock. Clock has started becoming slow or some erratic reading is coming. And one day it will have something around how much? Say 0.5 volt, clock has stopped. You can still say, sir 0.5 तो है, फिर भी clock क्यों नहीं चल रहा है? Not sufficient potential to drive the clock. I am giving you only half roti. Go and plow the field. Why are you not plowing? Enough potential is not there. Feed me a little bit more. Then I get potential. Then I can do work. Potential means energy. Energy means work in physics. So if this has potential, this only can do work. It is doing work, na, ultimately. अभी समझ में आया? Connect a voltmeter and this is your study lamp. Okay, you have connected your study lamp like this. You also connect one voltmeter here. The moment there is a power failure, what will happen to the lamp? It will turn off. The voltmeter will immediately show 0. Why? Because this point is no more charged. What is the difference between the lamp and this point? 0. They are at the same potential. They are at the same. If you draw a geometric diagram, their potential is same. For the lamp to glow, the plug point should be here, the lamp should be here. Then only that smart little fellow Q can come to the lamp. So imagine it like water. The water can come down only when there is a difference in potential. So electricity can be studied parallel to plumbing. It becomes easy. So यहाँ पे वही हो रहा है. As soon as the power is restored, this glows. What will the voltmeter read? Again 220. So when you start saying बोर हो रहा है, कुछ भी करने को नहीं है, basic electronics is a very cheap and interesting hobby. Is one of the most cheapest and interesting hobby because you see things happening. When you will see that you have lit a lamp or a LED has glown, your happiness will come. Then you see you can flash the LED also, more happiness will come. Then when you control the flashing, I will flash it every 5 seconds. Tuck, tuck. Okay, this. Then I can dance 2 LEDs together. Every time these things happen and you feel, oh wow, I'm designing a traffic light now. Stop, look, go. I'm designing the police blue, green, blue, red. I can do that. Can the LEDs dance to my voice? Can the LEDs dance to my voice? Then in your study table, you put a lot of lights and all. Na? Instead of lights, you can go into YouTube and see these projects. VU meter. People will put a LED strip around, control it with a microcontroller. You can do at your age and then start play music. Gehra hua, all lights will go and then it will all go. Different patterns which you see in discos, pubs. How are they controlling? You can do those things at home also. And then you will never feel boredom. What you gain in this? You gain another skill. Tomorrow, you can trade this skill for earning money also. लेकिन घर में बैठ के खाली मम्मी बिस्किट दे दो, ओके ना नहीं, खाली ये कर दो, 2 दिन बाद इसमें ही पेन हो जाएगा. चॉइस इज योर्स, व्हाट यू वांट टू डू. इसको करने के लिए कोई स्पोर्ट्स छोड़ने की जरूरत नहीं है. एंड इमेजिन इन द डे गोइंग फॉरवर्ड, it's your advantage. At night 8 o'clock, if there is a power failure in a house, you being an engineer are also dependent on that chappal cladded guy. Till he does not come, you stay in darkness. That is the most shameful day for you. तुम्हारी education that day, flush your mark sheets into the toilet. मैं तो नहीं उठता हूँ, जरूरत ही नहीं पड़ती.